Okay, in this video we'll be looking at volume, trying to find the volume of three-dimensional shapes. Whenever we're talking about volume, we mean how much stuff you can fit inside the shape. So today, your answers will be the amount of, think of it as a liquid if you like, or just the amount of space there is inside the shape. That's what all today's questions are figuring out. Now we'll do quite a few examples because they can be quite quick, so we'll move through as many different shapes as we can in this video. Pause whenever you need to so you can answer the question before me, stay ahead of the black texter. Okay, if you haven't already, draw that shape please. You need your formula sheet and you need it all filled out. I haven't done it for you this time because your book does a pretty good job of explaining it. Just find each of these shapes on the pages that I've set in the lesson plan and put the formulas down here. We'll use some now so you can get a bit of practice at them. Okay, now that you've got that shape, find that shape on your formula sheet, write the formula next to it, and then label these numbers with what letters they are to match up with your formula. Do that now. Okay, that's the formula you should have written down, and usually we call the one across the bottom the length, the one over here is the width, and the one from between bottom to top is the height. With this particular shape, it doesn't actually matter which one you call which because you're just timesing them together, you get the same answer either way. Okay, now pause the video, swap those letters for the relevant numbers, and I'll do the same. If you ended up with this equation here, you are correct. Press pause again, type in your calculator, find the answer. If you got 120 centimeters cubed, you are correct. The first thing I want you to take note of is this is now a 3, not a 2 anymore. We put a little 2 there whenever we're talking about area. We always put a 3 there whenever we're talking about volume. So if you wanted to help yourself remember, just like we put little centimeters squared and meters squared at the top of this page, up the top of that page, if you wanted to, next to volume, put a little centimeters cubed and millimeters cubed to help you remember. Okay, I'll draw another shape and we'll try another one. Okay, here is our next shape. Draw that, identify what shape it is from your formula sheet, and write the formula next to it. Go. All right, it's a cylinder, and that is the formula for a cylinder. We've only got 2 letters here, which works quite well because we've only given 2 numbers here. Label which one is which. We're getting pretty good at this now, I would imagine. So we know that R stands for radius, the R goes up here, and that H stands for height, that goes there. Now, swap the letters for the numbers, get a new equation. That's what your equation should look like once you've swapped the letters for the numbers. Your calculator will do the rest now. Type it in, get your answer. Let's go for 2 decimal places. The correct answer is 2309.07 centimeters cubed on the end, don't forget. But if you got that, you are correct. All right, I'll wipe the board. We'll do a couple more. All right, here's our next shape. A bit tricky to see, a bit harder to draw. Think of it like a Toblerone packet. Okay, this is like a Toblerone. So it stands up and you've got a triangle at each end of the shape. I'll give you some numbers. The easiest way to draw that is to just draw 2 triangles above each other and then just connect all the corners together. All right, across the bottom, 6 centimeters. The height through here, let's say that height of that triangle there, 4 centimeters. And that distance there, 10 centimeters. All right, decide what shape that is from your formula sheet and write the formula next to it. Okay, this is a rectangular-based pyramid. So if you found rectangular-based pyramid, that's the formula you should have written down. The first thing that I hope stood out to you is that there are 2 H's in this formula. It's very important that that's a lowercase h and that's a capital H. And you'll see why when we label. So let's try and label now, and I'll do it with you. Lowercase h, capital H. See if you can work out the difference as we go. That first part of the formula should look familiar because half times base times height. If you flip back to the front page of your formula sheet, that's the formula for the area of a triangle. So those numbers there relate to the triangle down the end here. So B stands for base, put that where you think it should go. H stands for height of the triangle, put that where you think it should go. Just like that. Now, this capital H, and you might want to make a note of this on your formula sheet, that capital H, yeah, it sort of does stand for height, But if you want to be more specific, I would write down on your formula sheet, the capital H stands for the distance between the two triangles. So the capital H is always the distance between the two triangles. Now that you've got that information, swap the letters for numbers, write down your equation. This is what your equation should look like now. Your calculator will do all the hard work, punch that in, get your answer. The correct answer is 120 centimeters cubed. If you got that, you are correct. All right, I'll give you one more shape and then we'll do one tricky one to finish off. Okay, here's our last shape. Pretty tricky to draw these ones and make them look three-dimensional, but imagine that to be like a basketball. Okay, so draw that, put the measurements, decide what shape it is, and write the formula underneath. All right, here's the formula. It is a sphere, and this formula for a sphere looks a little bit different to the rest. So there's two things that I want to point out. I want you to make sure you're very clear. Make sure you've written it down as a fraction, 4/3. It doesn't matter why it's a fraction 4/3, it just is. So you type it in your calculator using the fraction button just like that. Last thing, a lot of students get this wrong. Look next to the R. That is not a 2. It's a cubed, it's a 3. Students often get mixed up because they've been writing pi r squared for so long through the rest of the chapter that they do it here out of habit. That's a 3 for this formula. Make sure you've done the same thing, please. Okay, swap the r for a number, write down the equation in a formula. Go. Okay, here it is. If you've written that down, you're correct. All you need to do is type it in your calculator and you'll get the final answer. Okay, there it is. 5575.28 centimeters cubed. Remember, if I don't tell you otherwise, go for 2 decimal places. Extra decimal places while you're working out, 2 decimal places in your final answer. Okay, I'll wipe the board. We'll do one tricky one, then you can start the questions. Okay, last shape is this. Now this looks a bit different because it doesn't look exactly like one single shape on our formula sheet. In fact, it's 2 shapes that have been stuck together. So this is very similar to what we were doing last lesson, where you've got 2 shapes stuck together. Today you need to find the volume of each shape separately and then put the answers together. Draw that. I'll give you the 2 bits of information that you need. I'll do it in a purple so it stands out a bit more. The radius across there is 6 centimeters and the height, so from here down to the very bottom of the last of the other shape, is 9 centimeters. Okay, what I would like you to do is, let's split them up into 2 shapes. We'll call the top one shape 1, we'll call the bottom one shape 2. Over here, I'd like you to draw shape 1, and over here, draw shape 2. Decide what shapes they are from your formula sheet and write them down. Shape 1's a little bit trickier because there's no shape that looks exactly the same as that. Pick the closest one. Go. Okay, here are our 2 shapes. I've used the sphere formula, but it's not a whole sphere. If you look, it's like half of a basketball, okay? Half of a sphere. So if this is the formula for a whole sphere, what do you need to do to it? You need to halve the formula. You can put a big fraction here and put a 2 underneath. You can write divided by 2 on the end there. It doesn't matter how you do it. You'll get the same answer either way. I'll be a little bit fancy if you like and say with the whole thing, I'm going to halve it or divide it by 2. And you can type it in your calculator like that. It does work. Here, this formula has a 1/3 in it because it's a cone. Doesn't matter why it has a 1/3 in the formula. It just does. Now, swap these letters. There's only one letter here and only... oh, half of it's missing. There we go. Now, there's your complete formula. Swap the letters for the relevant numbers. Okay, once you've typed in your formulas, put them in your calculator, you end up with this answer here. Your calculator has done all the work. I've kept it at 3 decimal places because when we're doing the working out, it gives us a more accurate answer if we can have 3 decimal places. And your final step, these 2 shapes have been stuck together. So you now need to put your answers together. Do that on your calculator. You'll have the final answer. And there it is. I like my final answer to be in 2 decimal places unless the question tells me otherwise. So I've rounded it off there, but it's given me a very accurate answer either way. 791.68 centimeters cubed is the final answer. Okay, Now you can work through the questions from the book.